third video for section 2.2. This problem, it gives us two functions. F of x is x cubed and g of x is x cubed plus 3. Let's talk just for a moment. What is the relationship between these? Hopefully you will understand. Hopefully you have had practice on this, that you understand that g of x is the same as f of x, only it has a vertical translation. It's f of x with a vertical translation. Let's see if I can get that word a little better for us there. Translation up 3 units. In other words, it is parallel to this graph. It's just going to be raised up 3 units. Every output of f of x is identical to g of x, except it has 3 more units added to it. So let's do as we have here. Let's sketch f and g, and then let's determine the derivatives at each of those points. Before we start that, let's go ahead and let's do some analytical work. What is the derivative of f of x? And again, we have a leading coefficient of 1, so that would be 3 times 1, x to the 3 minus 1, or 3x squared. And the derivative of g of x would be the same thing for the first term, plus 3, and then remember the 3 here has an x to the 0 attached. 3 is the same thing as 3x to the 0, so this would be 0 exponent times x to the 0 minus 1, or simply 3x squared. Interesting, these are the same thing. What do these represent? And these are functions whose output is the slope of a line tangent to a curve at a point. Now, let's go ahead and take a look. So take your inspires. Let's add a new graph page, and we're going to put in x cubed. So we'll take x to the 3rd power, and we'll graph that. And press tab. Let's get that entry line back. And now we're going to put in g of x, so that's x to the 3rd power, and bring the cursor down, plus 3. And it's going to be identical, except it's going to be up 3 units on that. Let's change the window slightly on here so we can see it better. Let's say we go from, let's say -1 tab to 3 tab 1 scaling, and we can go then from -1 tab, and let's go to 8 tab 1, and we'll press enter on that, and there's our 2 curves. We're wanting then, back on our graph, to determine the derivatives at x equal 1. So let's go ahead and let's place a point on, and we're going to place a point 1 on each curve. There we go. And of course we're going to go back in and change the coordinates so that they are both having an input of 1. The points are vertical, and notice that the outputs. The output here is 1, add 3, the output here is 4. Okay, we are looking at the derivative, and again the derivative is the slope of the tangent, so let's go ahead and build a tangent, draw a tangent to each of those points. And let me extend these just a little bit. There we go. We're looking for the slope, so we will go in and do a measurement and the slope. And the slope is 3, and the slope is 3. So we have then tangents at points on parallel graphs. The tangent lines are parallel. That means they have then the same slope. Let's see what else. Sketch the tangent line. What's the relationship between the derivatives of f of x and g of x? And so we would say that the derivative of f of x equals the derivative of g of x. Okay, let's go on to the next problem. We've got some application problems here, and again, you're in business calculus, so we want to be sure we have a lot of applications that you can relate to back to your business courses. So let's see what this problem says. The sales, S, in millions of dollars for, and I apologize, that's a typo there, so this should be for, Scott's Miracle-Gro Company from 1999 through 2005 can be modeled by, and so this is our function in terms of t, where t is the year, t equal 9 corresponding to 1999. Problem, the first question then says, determine the slopes of the graphs of for the years 2001 and 2004. Now the slopes of the graph, you have to interpret this. Slopes of the graph, that's the same thing as saying the slopes of the tangent lines. So slopes of the tangent lines to the curve, or to the graph, for the years 2001 and 2004. First of all, let's decide if 9 corresponds to 1999, what corresponds to 2001? Well, that would be a t of 11, time 11 years, and t equaling 2004 would be then 14 years. So if we're going to determine the slopes of the tangents, we need to have the derivative with respect to t. Be sure you use the right coordinates there, or variables there. And we've got 1, 2, 3, 4, 5 different terms, so 5 different derivatives to take. So we're going to have to very carefully write these out. So it's negative 1.29242 times 4, t to the 4 minus 1, which is 3, plus 69.9530 times 3, t to the 3 minus 1 squared, minus 1364.615 times 2, t to the 2 minus 1, or t, plus 11,511.47 times 1, t to the 1 minus 1, or 0, minus this quantity. It's a constant term, so it's 0. That's our derivative value at, in the general sense. Now, in order to continue this, we'd want to multiply those out. And let's see, I'm going to use my notes here. You can multiply those for yourself and make sure. I have negative 5.16968 t cubed plus, okay, let me check my work here. Okay, so this would be plus 209.859 t squared minus 2729 0.23t plus 11,511.47. Okay, I'll do that again. 11,511.47. Okay, now the problem says determine the slopes of the graph at the year 2011 and 2004. So we want the derivative at 11, and then we'd want the derivative at 14. Now, in order to help us out, the best thing we can do would be to use the Inspire and to put those values in. I'm going to just go ahead and work on this. If I put 11 in here, my answer will be 2.03492, and over here the answer is 249.012. What we need to do is to be able to interpret these then. If this is the model of sales, so this would tell me how much the sales was in any year. If I put 11 in there, it'd tell me how much money or how much money in sales the company had. The derivative, though, is a little different. And so this would be interpreted as 2.03492. Now remember, we're talking about millions of dollars. So this would be millions per year. Now let's go back and make sure. Is it an annual? Yes, per year. For each additional year when t is equal to 11. In other words, this is how much more in output, this is the amount in output that we're going to get for each additional year. This is the instantaneous. So when in 2011 the sales amount was increasing by this many million per year. Over here we would have the same discussion per year. So sales was increasing this much per year for each additional year. Now we need to know when t is equal to 14, or in $2,000. So let's say this, sales increased that much. We'll add that statement over here too. Sales increased that much per year for each additional. Let me show you how I came up with some of those values. First of all, I went in and defined the function. We've done that before. That again is under Menu and Actions and Define. And then I took the derivative of the function. Then to find the derivative at a point, I went back and used that notation. If you go into, and on the touchpad, if you do Control equals, you have then the symbol for at the point, x equaling 11. I'll show the other version in just a little bit. We came up with that. If I come up here and grab that again on the other model, it's the key right here beside the Control key at x equaling 14, and we have that. I'll come back on the next video and show you some graphing information.